It's not the same thing, but you do the same thing. If that makes any sense. Your example problem under the remainder theorem is f of x is equal to x to the third minus 4x squared minus 5. And we want to know, is it divisible by x minus 3? Okay, so divisible is 30 divisible by 8. Can you divide 30 by 8? Yes. But when we say divisible, what are we looking to happen? Evenly, right? We want a remainder of 0. And we won't get, if I do 30, then I'm going to get 3 and I'm going to have a remainder, aren't I? It's not going to go in there evenly. But if I said 32, then I would have a remainder of 0 because 8 divides. So that's what I'm looking for. I'm looking for, do I get a remainder? If I do not, if I do this and I get a 0, then it's a factor and I have no remainder. So what I'm going to do is, what is this 0 right here? What is this x-intercept? If I have x minus 3, the x-intercept is, remember it's that opposite thing with those? So I'm going to say f of 3. And that's going to be just that easy. Don't make it into anything more than that. If I get a 0, then it's divisible. If I don't, whatever I get, that's going to be my remainder. So 3 to the third minus 4 times 3 squared minus 5 gives me a 27 minus, 36 minus 5. 36 minus 5 is going to give me a negative. So is x minus 3 a factor? No. What would be the remainder of x minus 3? Negative 14. Okay? They're calling it the factor theorem and the remainder theorem. It's not the same thing, but you do the same step. All right? All I had to do was find out what was f of 3. Okay? If I went to your example problem, down at the bottom of the page, I have f of x is equal to negative 4x to the third plus 5x squared and I want to know, is it divisible by x plus 3? If not, what's the remainder? So what am I going to plug in? Instead of f of x, I need f of, So I've got negative 4, negative 3 to the third, negative 3 squared, plus 8. 27 times 4, 108. Checking my math behind me, guys. Am I going to get a 0? No, I'm most definitely not going to get a 0 on that, am I? So what is my remainder going to be on that one?
You said 161.
I've got an error in here somewhere and I'm not finding it. Is anybody finding an error for me? Negative 3 is negative 27 times negative 4. That's got to be a 108, doesn't it? No, because that's a squared. So that would be 9 times 5 plus 8. I am not seeing my error, so we're going to say that. Ma'am?
Oh, wait, it's a negative 4. Never mind. I was about to say it should be a negative 108, but there's a negative 4, so I don't know.
Well, we're going to say that the textbook is wrong then. All right, so my answer is no. And 161? And remainder 161.
Do you want no and the remainder you just want?
It's going to come probably at you in 2 different questions. Some questions will say determine the remainder. Others will say, is it a factor? And when it says, is it a factor, your answer is just going to be yes or no. And then other times, if it, what is the remainder? Okay. All right, let's try one more and see. So 14, I've got f of x is 4x to the 4th minus 15x squared minus 4. And I want to know, is it divisible by x minus 2? If not, what is the remainder? Four times 2 to the 4th minus 15 minus 4. So we have 4 times 16 is 64. Whoops. 15 times 4, 60. I believe that is a 0. So my answer is yes, it's a divisible by. Yes? Okay. So this is 2 things. When we get into the real problem of tonight and we're trying to solve our polynomial, when we start testing possible zeros, this is what we're going to be using. We're going to be using this tool to find a yes or a no. So I can determine, it's this tool or it's synthetic division. And I think this is a little bit shorter than the synthetic division. We'll probably be using both. All right, determining how many, because tonight what we want to get to is factoring these polynomials. So if I have x squared, you guys know how to factor that, right? You know how to get it into those two binomials. But what if I have x to the fourth or I have x to the third? That's what I want to get through tonight. I want to be able to factor these polynomials. One of the tools I'm going to use is that factor theorem. The other is going to be my Descartes rule. And all we're going to be doing is counting the changes in the sign for f of x. And this is not obviously what your textbook is going to say. This is just me putting it in my words. Count the changes in my signs for f of x, f of positive x, and f of negative x. And that's going to tell me how many of my numbers, my roots, my zeros are going to be positive or negative. So in their example, they have negative 3x to the 7th plus 4x to the 4th. Okay, and what I am looking at, what I am focused in on is these signs in front of each term. And throughout the term, how many changes happened. Now this one is positive x. So I am right now looking for my positive zeros. When I look at this, I go from a negative 3 to a positive 4. There's one change. Go to the next sign, it stayed positive, no change. Go to the next sign, there's another change. So there's 2, stayed negative. So I have 2 or none positive zeros. Now, this part right here, you're going to skip one. Like if you count this whole thing out and you count 7 changes, you're not going to say 7, 6, 5, 4. You're going to skip one. You're going to say 7, 5, 3, 1. You're always going to skip over 1. For this polynomial, I have a maximum of 7 zeros. That means it's going to cross that x-axis or touch that x-axis a maximum of 7 times. 2 or none of those zeros are going to be positive numbers. Okay? Now I got to find out what is f of negative x. What happens to negative 1 if I raise it to an odd exponent? Stays negative. What happens to negative 1 if I raise it to an even exponent? Changes it, right? So this is going to be to that odd exponent. So if I do negative 3 times negative x to the 7th, that's going to stay negative, isn't it? Now I've got a negative times a negative, so I change. Then I have plus 4 times x, negative x to the 4th power. Anything going to change? No. So I have, because that changes to positive, so now I have plus 4x to the 4th. Is it going to change? Is this sign in front of the 3 going to change? What happens to a negative x raised to an even? Should I change this sign? Plus 3x squared. Then I've got minus 2 times negative x. So that's an odd one, so that is going to change. Minus 1. How many negative zeros am I going to have, guys? How many changes? Positive, 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 negative. 1 change, right? So that means I will have 1 negative 0. On the beginning in chapter 1, you were given f of x is equal to x minus 3 times x plus 2. You were given this, right? And I was asking you what the zeros are. And it's easy when I give you this because you can say, well, 3 and negative 2, right? Well, now we've got to find this same answer when we're working from this equation. Okay, we got to get this guy factored down. So that's what we're doing here. I know that 2 or none of them are going to be positive, and I know 1 of them is going to be negative so far. That's what Descartes' rule is telling me. Let's try that one more time. That was the example problem. Let's look at 21. Negative to positive. Change. So I've got 3 or 1 positive zeros. When I get this, what's my max number of zeros? 7. All right, every time it's odd, I'm going to have to change that sign in front. So if I do negative 4 times negative x to the 7th power.
Why'd you say 3 or 1? Where did the 1 come?
You always come down and just skip over 1. Like if I say 4, I'm going to say 4, 2, or none. If I say 3, I'm going to say 3, 1. 3 or 1. If I said 5, 5, 3, or 1. Okay? So this one's going to give me a positive 4x to the 7th. Then I've got plus negative x to the 3rd. So that's going to give me a minus x to the 3rd. Then I have minus negative x squared. That's even, so that's not going to change. Minus x squared plus 2. So how many negative zeros am I going to have?
2.
Positive to negative, stayed the same, went back to positive. So 2 or 0, negative zeros. So when I get my answers, I know that 3 or 1 of them are going to be positive, 2 or none of them will be negative. I mean, until we start using it in the problem, it's like, that doesn't make any sense. But do you think you can count them up for me? Remember, every time it's odd, the sign in front's going to end up changing. If it's even, the sign in front will stay the same. Okay. So here's what we got to do. We got to find out all the potential rational zeros. Our next step in solving this is we're going to be looking at, I'm looking at your example 4, and in 4 we're going to start using all the stuff that we've done tonight. I have f of x is equal to 2x to the third plus 11x squared minus 7x minus 6. What are all the possibilities for those zeros? I'm going to get it from getting the factors of p over the factors of q. The hardest part about this is that they set it up backwards. P is my last term, my last constant. Q is my leading coefficient. Okay? Factors of P are 1, 2, 3, and 6. Factors of Q are 1 and 2. I got to make a list of all my factors of P and put them over all my factors of Q. So I'm going to start with 1, and I'm going to say plus or minus 1 over 1, plus or minus 1 over 2. 1 over 1, 1 over 2. I'm going to move over to 2. 2 over 1. All of these are positive or negative, and 2 over 2. Plus or minus 3 over 1. Plus or minus 3 over 2.
So you use the first and last?
I use P over Q. Everything on P's got to go over everything. This is this one. This is this 2. This is this 1.
Okay, yeah, I got that for you.
Okay. 3 over 1, 3 over 2, plus or minus 6 over 1, plus or minus 6 over 2. Now some of these have doubled up. So 1 over 1 is a 1. Plus or minus 1/2. Plus or minus 2. 2 over 2, that's a 1. I already have that. Plus or minus 3. Plus or minus 3 over 2. Plus or minus 6. And 6 over 2 is another 3. And I already have that. Okay? Now we're not going to do it with this problem because it's not worked out for that. But we're going to take these numbers and go back with that factor theorem and find out who works. Remember our first was who is divisible? That's what now we've got trials here. These are possibilities. And I'm going to I always start with one, because why not start with the easiest and hope for the best? And we're going to use our factor theorem, and we're going to plug them in. And we're going to find out what happens.
Question. Are
Mhm.
we plugging in until we get 0?
Until we get a 0. If we don't get a 0, these are possibilities. These are not answers. These are possible answers.
So if there's no 0,
You move on to another one. Okay? You're looking for a 0. That's why I say I always start with 1. I always start with the easiest.
You either plug it in as positive or negative.
I would start as a positive. If that don't work, I'm going to do a negative. So I'm going to say 2 times 1 to the third plus 11 times 1 squared minus 7 times 1 minus 6. And I'm looking for somebody to come out as a 0. So I would have what? 2 plus 11 minus 7 minus 6. Do I get a 0 there? Yeah. So I know what I have. X minus 1. Now how would I find out the rest of it, guys? I got to go back to last week and use my synthetic division. How do I find out the rest? I'm going to divide 2, 3, 2, 1, 0. So 11, negative 7, negative 6, and I'm going to divide by 1. How do I do synthetic division? Remember that from last week? Drop the 2. 2 times 1 is add. 13 times 1 is 13. What's negative 7 and 13? 6 times 1. And there's my 0. So now I have 2x squared plus 13x plus 6. It gets to be a lot. We're going to fill in like a whole page doing one problem. Okay? So we decide how many maximum number there are, and that I'm just going to look to that degree. Then I'm going to use Descartes' rule, and I'm going to find out how many positives and how many negatives I'm going to have. Then I'm going to list all possible, and then I'm going to test them out. Okay? Now, let's see. I wouldn't have to do any more on this one. Could I finish factoring that out? That's a quadratic. What could I multiply to get a 12 and add to get a 13? So 12 times 1. So I have x minus 1. Then I'm just going to work on that. 2x squared plus 1x plus 12x plus 6. How do I factor that? Did y'all do AC method in high school? Does this mess look familiar? At all? Kind of? No? Grouping? Okay, so I have this x minus 1 What could I factor out of 2x squared plus 1x? So that would leave me with 2x plus 1. And what could I factor out of 12x plus 6? And that would leave me with 2x plus 1, right? So that leaves me with x plus 6 and 2x plus 1. So what are my zeros? I have a positive 1, a negative 6, and a negative 1/2.
So after you finish the synthetic division problem, you did the AC, whatever.
Then I just factored this part. And you probably did trial and error. When you were in high school, you said this is 1 and 2, and this is 1, 2, 3, 6, and just did trial and error when you factored. It was last week. Come on. Well, I just always did the AC method. I thought that was a lot easier. But now not all of them are going to have. All right, let's try it out. Ground zero. What happened? Is that a band brought in, or is that Troy's?
I think they have speakers outside. There's a whole bunch of people outside.
Okay. Potty time, huh? All right. We're at 45. And we're going to start with, and there's a lot going on with this. F of x is equal to x to the third plus 2x squared minus 5x minus 6. All right, I need to find out what the zeros are. Okay, first thing I'm going to do is what is the maximum number of zeros I can have? How many times will this polynomial cross or touch the x-axis? 3, right? That gives you your maximum possibility. There are a maximum of 3 zeros. Okay? This is f of positive x. How many positive zeros are possible? How many changes? Positive, positive, negative, negative. Okay, so 1 positive. What is f of negative x going to look like, guys?
Negative x.
2 to the third. Is this one going to change?
2x squared.
There you go.
And then 5x
That's going to change, isn't it?
minus 6.
Minus 6. So how many of my zeros are going to be negative? How many changes do I have? From here, and then from here. So 2 or 0 that are negative. All right, I need my factors of P over my factors of Q. What's P in this problem? And what's Q?
1.
So that's nice because it's all over 1, right? So it's just going to be possible answers. Plus or minus 1, plus or minus 2, plus or minus. Oh, no. Okay, So we determine maximum number of answers that we get. That's going to be 3. We know that we have 1 positive, 2 or none that are going to be negative. And we know these are my possibilities right here. These are my possible rational answers. So how do I start finding out who is who?
Just plug in.
Plug it in. So I'm going to say 1 to the 3rd because I'm going to start with my positive 1. Guys, if you want to start with negative 6, start there. That's up to you where you start. I always just start with the easiest one. Plus 2 times 1 squared minus 5 times 1 minus 6. I don't think so. 1 plus 2 minus 5 minus 6. Positive 1's a no-go. What about negative 1? Negative 1 to the 3rd plus 2 times negative 1 squared minus 5 times negative 1 minus 6. So I get negative 1 plus 2 plus 5 minus 6. I've got 7 negatives and 7 positives, right? So that gives me a 0. All right. So I know negative 1 is part of it. I know that part of my answer is going to be x plus 1. So far, okay?
What is it, multiple?
Hmm?
What is it, multiple? I plugged in 2 and then 0, 2.
You got 2 also? So that means,
Well, it says 2 or 0 negative zeros. So if you have 1 negative 0, then you have to have 2 negative zeros, right?
2 negatives, you should.
Okay.
Because you can't have 1.
Okay.
Yeah.
Give it that's 1 now. Okay.
You have to.
So positive 2 worked?
Yes.
Okay. So we're going to have a positive 2. I'm going to go the long way around, though, and I'm going to do my synthetic division. So my factors are 1, my coefficient, not my factors, I'm sorry. 1, 2, negative 5, and negative 6. And I need a negative 1 out here. Drop the 1, right? 1 times negative 1 gives me another 1. 1 times negative 1 gives me a negative 6. Negative 6 times negative 1 gives me a positive 6. So there's my 0. All right, I've got x plus 1.
Go ahead.
You sure?
So like, will you ever have a problem where the exponent, like you have to get it to 0, you know what I mean? Like f of x is 3, 2, 1.
And you have to put in a 0
Yeah.
so that you have all, you don't, yeah. Sometimes you can't do this with any skips. Sometimes you're going to have to put a 0 in there. Like if there wasn't this term right here, where that 2 is at, I'd have a 0. Okay? No skips on your exponents down. That's why you'll always see me, okay, 3, 2, 1, 0. No skips. Does that make sense?
Yeah.
Okay. All right, so here's what I got left. X squared plus x minus 6. I need to factor that. What can I multiply to get a negative 6 and add up to get a positive 1? What does this guy factor to? 3 and negative 2. So x minus 2, x plus 3.
Where'd you get the x squared plus x minus 6 from again?
Right here.
Okay.
When I did my synthetic division. When we do this shortcut here, I'm not writing everything down. I'm actually dividing by x plus 1, right? I'm taking an x out of here. So if this started as x to the third, what I get left with is 1x squared plus 1x minus 6.
Okay.
And that's gone. Okay?
And then we have to do that again.
Then if this factors, you got to factor it. Now there's going to be problems where you're going to have to go back to this and do some more trial and error to find another one.
That's what I was asking for the positives too, so we have to do that all over again.
Most times what you get left with will factor somehow. But sometimes it won't, and you're going to have to just do another trial and error. Use your factor theorem again.
And then we have to do the synthetic again.
Mm-hmm. If you have to do the trial, because you got to find out what's left here, right? Okay, so we started with, I know I have a maximum number of 3 answers. I knew that one of them would be positive, 2 or none of them would be negative, and that was a really great point. I should have pointed that out. I'm proud that you did that. It has to be 2 or none, right? So that was then we list our potential possible answers. Or did all of these come out being my answer? No, these are just potential possible answers. Trial and error. Get something, go to synthetic division, and then hopefully we can factor the rest out. Yes?
Do you have to do synthetic division? Because I don't remember doing that in high school. I just remember trying literally everything until you got which takes a long time, but I don't remember doing synthetic division.
Okay. I think there's a video on synthetic division. If do what you got to do.
Yeah.
But I think we worked on a video on. Is there a video on when we did synthetic division posted in Canvas? I don't know. There might be. And YouTube videos are great. I love YouTube. Okay. Yes. I mean, you can go that route.
I was gonna say, because I missed a couple classes because my parents, so I've been having to take care of them. They've been having surgeries and stuff.
Oh my goodness.
So I'm trying to catch up.
You know what? Welcome to life.
Yeah.
It's a catch-up thing forever.
Oh yeah.
All right. So I'm going to jump over 48 and go to 51 because there's something, when they talk about those possibilities, they call these your possible rational solutions. Okay? That doesn't give you always all of your solutions. Sometimes you just got to rely on what you know with factoring. So I'm going to go to 51. We have f of x is equal to 2x to the 4th. All right, total maximum possible answers that we can get. Okay. How many of them will be positive? stays the same, 1 change.
2.
So 2 or 0, positive. What about negative? Who all is going to change? Stays the same because that's even, changes because that's odd, stays the same because that's even, changes because that's odd, right? Odd exponents make it change. 2 times negative x to the 4th stays a positive 2x to the 4th plus negative x to the 3rd makes that change to minus x to the 3rd minus 7 times negative x squared stays the same. Negative 3 times negative x. How many of them are negative?
2 or 0. Is
1.
it gonna be always like what's left? So like if you have 4 maximum possible and the positive ones are 2 or 0, then is the negative ones always gonna be like what's left? So you, does that
We
make
don't
sense?
have to get 4 answers.
What I'm talking about, like of the possible ones, is it always gonna be like if it's 4 maximum, it's 2 or 0 positive? Then is
And
the
2 or
negative
0
one always gonna be
negative.
2 or 0?
Usually, I'm not going to say every time. Okay? And like I said, we don't have to get 4 answers.
Yeah.
That's the maximum possible.
You could get it on.
You could get none. Same, no change. So 2 or 0 negative. All right. I have 1 times 2 and 1 times 3. Believe it or not, out of all of this mess, this is where we have the most errors. Who's P?
3.
Okay, remember it's got to be P over Q. And the last constant is your P, and your first leading coefficient is your Q. So I have 1 over 1 and 3 over 1. I have 1 over 2 and 3 over 2. So that gives me a positive or negative 1. You know where I'm going to start. Do you want to start with something different? It's completely up to you as to which number, because we are in 100% trial and error is what we're doing. So if I have 2 times 1 to the 4th plus 1 to the 3rd minus 7 times 1 squared minus 3 times 1 plus 3. I've got 2 plus 1 minus 7 minus 3 plus 3. I think that's going to give me a negative 4. All right, so 1 doesn't work. What about negative 1? Two, negative 1 to the 4th. So I've got a negative 2 minus 1 minus 7 Sorry, that's a positive 2. Minus 1, minus 7, plus 3, plus 3. And I believe that works. 1 minus 7 plus 3 plus 3. Okay. So far, we good? Alright. So we're gonna take our negative 1, and we're gonna do synthetic division. Now, what I'm gonna do is I'm gonna list my coefficients. And I can't have any gaps, so I'm gonna check my exponents. 4, 3, 2, 1, and 0, x to the 0. So I'm gonna write those numbers down. I don't have anybody missing. 2, 1, negative 7, negative 3, and positive 3. My first step is just to bring down that first coefficient. So I'm going to bring that 2. Now we're going to multiply, put our answer here, and add.
Does that negative 1 change?
Wait a minute, where now?
We use negative 1.
I was just asking for the,
Yeah, this is negative 1.
I was just asking when you do the synthetic division, does it swap?
No, like when I write this in the binomial, this is negative 1, and I'm going to write that as x plus 1, right? Okay. So 2 times negative 1, that's negative 2. Add, and I get negative 2. Negative 1 times negative 1, that's a positive 1. Add, and I get a negative 6. Negative 6 times negative 1, positive 6. Add, and I get a 3. 3 times negative 1 is negative 3, so I'm done. So I have x plus 1, that's that negative 1, times 2x to the third minus 1x squared minus 6x plus 3. 4 terms. Before we start, now a lot of times this is where I'm going to go, I got 4 terms here still, so I'm going to go to my positive 3 and do another trial. But before I do that, I'm going to want to look, because sometimes, can't you factor 4 terms sometimes by grouping? Could I group those up? There's a lot of similarities there. I'm going to leave my x plus 1. What could I factor out of 2x to the third minus x squared? X squared? If I took out x squared, I'd have 2x minus 1, wouldn't I? What about negative 6 plus 3? Now who's my common factor?
2x minus 1.
Okay, so now I have 2x minus 1, and I have x squared minus 3. So my answer is x plus 1 times 2x minus 1, x squared minus 3. Now, I have a negative 1 here. I have a positive 1/2 here. What about this? What would I get if I factored that? If if I set that equal to 0, how would you solve that? If we went back to chapter 1, section 2, and I said x squared minus 3 equals 0. Add the 3 to both sides. And take that. X equals plus or minus the square root of 3. The square root of 3 didn't show up in my possible answers. Why not?
Because it's not a rational number.
There you go. It's not rational. These are rational, right? And it did show up, so that's okay. I have a positive square root of 3. I have a negative square root of 3. 2 positives and 2 negatives. They're not rational, but they are real, right? Okay. What you think? This is one of those things that only start to make sense when you are by yourself and working through that problem and getting it step by step. How we doing on time? Doing good. We can do one more of these. Let's see how far. Everybody signed in, right? Attendance one more time. I'll go ahead and tell you, I believe on this one you are going to have to do your factor theorem twice. nice when your leading coefficient's a 1, isn't it? Positive 1 didn't work for me.
Ms. Wood,
Mm-hmm.
after you, after you find your synthetic, after you do synthetic division, you get your equation, what do you do after that?
If you look at those 4, you got 4 terms left?
Yeah.
And if you look at those and it's not going to factor, you can't like group it, then you're going back to pick another possibility.
Alright.
Um, okay, so -1 is gonna work for me. X plus 1. I'm gonna write down, I'm gonna be dividing by -1. 1, I've got 4, 3, 2, 1, 0, no gaps. So 1, -1, -6, 4, and 8. Bring down that 1. -1, -2, 2, -4, -4, +4, 8, -8, and that's gone. So this was x to the 4th, so now I have 1 x to the 3rd minus 2x squared minus 4x plus 8. I think that would factor. Can we factor that by grouping?
Yeah.
What could I take out of there? Just the x squared is gonna leave me with x minus 2. And then -4
Yeah.
out of this one.
Yeah.
And that's gonna leave me with x minus 2. So now I have x plus 1 times x minus 2 times x squared minus 4. Anything else I can factor there? There you go. This is my difference of squares, isn't it? So x plus 1, x minus 2, x plus 2, x minus 2. What's my graph going to do at -1?
Across the x-axis.
Cross the x, and at -2? Cross it. But what about at +2?
Also cross it.
Multiplicity of 2. Say you're going to touch and go back, right?
Oh.
If you have that multiplicity of 2, you're going to touch and go back. What would the end behavior of that polynomial look like?
Oh, correct.
Right? Because I've got an even and it's positive. So left and right is going to be pointing up. What are my turning points? How many times is it going to turn? 3. Leading coefficient -1. Okay, not leading coefficient, I'm sorry. The degree -1. Okay, guys, practice that. And I will see you online, 6 o'clock
The link to print out the study guide.
on Sunday. On Monday, I will have a hard copy here.
Can you advance that for now? To the final product. Yeah.
There? Okay.
And did you get my makeup test? I think it was last week or whenever we did.
Yes,
Okay, just
Yep.
making sure.
I got it.
Thank you.
Thank you.
Miss White, I have a question.